Hello, thank you for checking out A1 Math, and today we're looking at exponential and linear functions. And what we want to do is take a description and write the equation and see if it is a increasing or decreasing. So let's begin. So this is what you want to do. Uh, you want to know if it's going up by a percentage or doubling or something like that. If it's doing that, then it's exponential. But if it's going up by the same amount, then it's going to be linear. So let's take a look at the first example. It says the enrollment at the school is initially $454. I'm sorry, 454 students and grows by 3% per year. So we're going to use function notation and we're going to replace the y in our function with e sub t. And the t is for time in years. So remember with our exponential function, the a is where you begin. So we begin at 454 and it grows by 3%. So it grows by 3% per year. Okay. So we'll take that 3% and add it with 1, and that's going to make us 1.03. And we're going to raise it to t. All right, now all we got to do is determine whether it's increasing or decreasing. And in this case, it is increasing because it's growing. So we're going to say increasing. Okay. Now, if it was decreasing, you want to subtract it from 1 when you make this right here. But since it's increasing, we just add it to 1. All right, now let's take a look at the next one here. It says a salesperson initially earns $50,434 per year, receives a yearly raise of 675. So since it's going up by the exact same amount every single time, then it's going to be linear, okay? And normally our linear function is y is equal to mx plus b, but I swapped it around because I want to start where we begin. So since we begin with $50,000 of 434, $50,434. That's what we want to put in for B. So I'm going to write it in function notation. I'm going to use S. And since it's yearly, I'm going to use T as well. So S of T earns at the beginning $50,434 and receives a yearly raise. So we're going to add that with how much he receives every year, 675. And then multiply by the year, whatever the year is. So that's going to be our T here. Okay. And since the money is going up, that's going to be increasing as well. All right. Now take a look at 3, 4, 5, 6, and 7. And make sure you determine whether it's increasing or decreasing and write out exponential or linear function. Again, exponential is a percentage or doubling or tripling or something like that. And linear is when you add the same amount every time. Okay, this should be what you get for 3, 4, 5, 6, and 7. Okay, so now we're going to take a look at comparing a linear and exponential function on the same graph and use it to real world problems. Okay, so next thing we're going to do here is we're going to compare linear and exponential functions on a graph. And we're using it in a real world scenario here. So it says compare the two salaries plans listed by the using a graphing calculator. Will job B ever have a higher monthly salary than job B? If so, how many months will this occur? So you got job A. Job A gets paid $1,000 for the first month with a $100 raise every month thereafter. Job B is $1,000 for the first month with a 1% raise every month thereafter. Okay. So notice how they wrote out the functions here. And since job A gets paid the exact same raise every year, that's going to be a linear function. And job B um, is an exponential because it grows. So eventually, what's going to happen is, and I'll show it to you. This is the linear here for job A, and it's going up on a straight line. And then job B is going exponentially. And what we want to determine is when will this red line cross here? So what you want to do is go ahead and type both of these functions in your graphing calculator. And then I'm going to show you step by step what to do as far as determining the intersection here on the graph. So let me show you. All right. So I'm going to start off with going to y equal. And I'm going to hit clear this out. And I'm going to type in both of the functions. So the first function was $1,000 plus 100 times x for the t here. And then the next function was $1,000 times the 1% raise. And raise that up to x. Okay. And then you hit graph. Okay. So now you have the graph. But what we want to be able to do is determine where that intersection, where it crosses it. Okay. And this is what you want to hit. And I'm going to clear this out so you can see step by step what to do. Okay. So the first thing you want to do is you want to hit second. Then you want to hit table. I'm sorry, hit trace to get to the calculate. And then you want to hit the number 5 so you can get to the intersection. And then next you're going to hit enter 3 times, but don't hit it right after each other. Wait a second after every time you hit it. So you hit enter, enter, then enter. Okay, and then it tells you the intersection. So you want to look at the x value because the x is the months. So we want to know at 363.9 months, 364 months, that's how many months it's going to take before the exponential function overtakes the linear. So job B will start paying more money in 364 months. All right, let's take a look at another example. Okay, so in this example here, um, and I didn't go over this on the previous one, but in this example here, her job A is 1,000 for first month with a $200 raise every month thereafter, and job B is 1,000 for the first month with a 4% raise every month thereafter. So it's more money there. So it got another $100 every month, but the percent of raise is high as well. So we want to determine when will job B take over and be you get paid more money from job B than you would be from job A. So right here, when we write out the function, notice how it has this S of A to the T. Basically, what they're saying is the salary is a function of the time and years, and they got the A for job A and the B for job B. So don't let that confuse you. Okay, so with job A, we begin with $100. I'm sorry, $1,000, and we add 200 and multiply it times the T in time. Job B, we start with the same 1,000 and we're going to add 4%. So we take that percent, change it to a decimal, add it with 1, and get 1.04. Okay, and now what we're going to do is type both of those functions in the calculator and see what we get. So I'm going to go back to y equal. I'm going to clear this out. Okay, and I'm going to start with 1,000 plus 400. Was it 400? Oh, 200. And times x. And then 1,000 times 1.04%. And we'll raise that to the x. All right. So now we're going to hit graph. Okay. And we've got it intersecting here. And what we want to do now is figure out where will it cross. And it seems like it crosses a lot earlier than it did in the previous one. So let's find out exactly, roughly how many months that's going to be. So I'm going to clear this out here just so you can see it. And then you hit second trace for calculate. Hit 5 for intersection. Then hit enter, enter, then enter. All right, so it tells us our intersection is at 68.5. So it'll take about 69 months before, um, 69 months before job B overtakes job A as far as how much money you'll get paid. So I'll come over here and put 69 months. So after job B will have a higher salary than job A after 69 months, and it's equal around about 69. All right, well, let's take a look at this example here and see if you can figure out which salary is going to be better, or when will job B overtake job A. Okay, so this should be what you get for number 6. Okay, so around about 50 months is when um, job B will be equal to job A, and then after 50 months, job B will be higher than job A. So even though you start off, the initial amount that you start off with is lower in job B is the better job after about 50 months, which is a few years there. 3, let's give or take. Well, that is it. That is comparing exponential and linear functions. I want to thank you for checking out A1 Math. Have a nice day.